Right, so what's here? Right, so vectors, we are focusing on 3 dimensions. Everything it didn't and add much is the same thing. We just adding on one more dimension, right? That's all. Right, so we should remember that OP, we call that the position vector, Lucas. And take off your headphones, please. Right, position vector of P. Right, this is called the position vector P. All right, what is PO again? PO is what? Nobody remember? How do we show opposite? Negative sign. So negative xi, negative yj, negative zp. All right, that's the way we show a change in direction, right? Everybody clear it up? Quick example on how to add and multiply. Let's say I gave you A, which is 2 minus 1, 3, and I gave you P, they are all vectors, and it's 2, 4, minus 1. Right? Let's say I ask you to find 2A plus B. How are we doing that? How do we find 2A? Multiply every single value by 2. So that will be 4 minus 2, 6. How do we find the vector P? 2, 4, minus 1. So 4 plus 2, that's 6. Minus 2 plus 4, that's 2. 6 plus minus 1 is 5. That's okay? Take it up. Add the x, add the y, add the z. Right? How do we multiply A by B though? If I wanted to multiply 2 minus 1, 3 by 2, 4, minus 1. How do we multiply two vectors? Anybody remember? How do we multiply two vectors? Multiply the x, the y, and the z, and add them up, right? Right? Because this is called what? This is called the scalar product or the dot product. So what that means is that we're going to get something scalar, right? So that's 4 minus 4 minus 3. 4 plus minus 4 plus minus 3, and we'll get minus 3. Right? So that's the way we find vector. Sorry, multiply vector. Everybody okay with that? Nothing new except you have one more direction to deal with. Right? How do I find AB? How do I find the vector AB? What is it? Yeah. A to O. Right. So close it. You're close. So therefore, in order for us to find AB, all we need to do is find A to O, and then find O to B. Right? That's it. A to O plus O to B, and we have the unknown vector. Just like Form 5, right? That's okay? Right? Only thing is a little bit new now. In fact, no, this is not new. If I ask you to find the angle here now, if I ask you to find the angle between two vectors, if I ask you to find the angle between two vectors, we simply have to multiply the two vectors and divide by the magnitude of their length. Remember this, some maths? Right? This is the formula to find the angle between two vectors. If theta is 0 degrees, then A dot B, sorry. Then A and B are what? What would happen if angle is 0? Vectors are what? No, the angle is 0 degrees. They are what? Parallel. They are parallel. Same thing. All right, well. Right? If 90 degrees, then A and B are perpendicular. Also, A dot B is equal to 0. Here. Yeah, no. Right, make a note of those two small things. Right, so that's everything from ADMAS that I need to know. Right, so what we have been learning is really finding the vector of a point. Right, if you were to combine points, like about 100 points, what you'll end up with? Huh? A line, yeah, a line. So our next step is to find the equation of a line. Vector equation of a line, right? And what happens if you connect a whole set of lines? It becomes a what? Huh? A shape. It becomes a plane. Right? So imagine this here as a plane. If I connect a whole set of lines, it becomes a plane. Right? So we have to find vector equation of a line and a plane. Right? I'm gonna give you one of this just to get a little small practice. Right, when you're done with doing part B alone. Right, you want to try part C of mine. Yeah, I'm sure for the realize what we have questions to do there, right? Right, part B only, yeah, part B only. Find the length of the line, or then give it a formula for length of line. Length of the line formula is length of the line formula is the square root of x squared plus y squared plus z squared. Oh yeah. It's supposed to come out from the or it can get some kind Oh yeah. So find the length of U and V and find the angle. It's Sunday morning. Right. That part is work it out, find the length and find the angle. What you all got for the magnitude of u? Root 15? How much? Oh, yes, yes. And what you all got for the root of v? 30? And last part, angle. Right, so that's root 14 or root 30. And when you multiply, I got 9. I got 9. I got 9. So theta is what? Right, all the people with the SPA, I will pass it here during the week, right? Who have to do the SPA? I want you all to pick all your own groups, what? I know how we do that, huh? Pick out something.
Yeah.
How much is that? Cosine inverse 9 over. Yeah, Somebody got 64 degrees? Yeah, 64. Choose it together. That is 64.
Yeah.
All right, good. That's just a quick review, right? What you need to focus on is vector equation of a line, right? That's the new stuff. So head up vector equation of a line. Right, next heading, vector equation of a line. Vector equation of a line. Right. So how do we represent a line? Not normally. Well, what do we need to represent a line? Well, y is equal to what? Mx plus c, right? So in order for us to get a line, we need a gradient and a point on the line. Correct? So we are going to do something very similar. Right? So as I said, right? In order for us to find the vector equation of a line, let's say I have this line, right? I need two things. I need a point on the line. Let's call the point on the line A. And I need to find a way to find the gradient of this line, right? But because it's a vector, I won't be able to find gradient. What I'll be able to do is to take its direction from a next vector. Let's call that vector B. Right? So if I ask you to find the equation of this line, let's call it R. The vector equation of this line is the point. Remember this in your head, right? Y is equal to mx plus c, right? It's equal to the point, which is x. Let's change it now. Let's change it to A, B, C. Right? That's the point. And then we need some direction. So we use this here. What do we know about parallel lines? Same gradient, right? So they basically have the same slope, right? So parallel lines are basically multiples of each other. So what you do is take the point on the line and take the parallel vector, right? And of course, this line will be a multiple of this. So the vector equation of a line looks like this. Point on the line and some multiple of the direction vector. Okay? This is called our direction vector. So the only purpose of this is to really give direction. Are you okay with that? So if I ask you to find the vector equation of a line, what you need is point, direction vector. Okay? So this is called the vector equation of a line. Right? We'll prove it in a little while. But I want to show you the other forms as well. Right? So what is here? Let's say R is some random point, X, Y, Z. Right? R could be any point on that line, X, Y, and Z. And A, B, and C is an actual point on the line. And B is the direction vector. Let's use that as A, B, C, D, E, F. Right? Well, what we could do now is take the vector equation of the line and write it in two different ways, parametric and Cartesian. Right? Watch this here. If I multiply this out, what will I get? I'll get ABC plus lambda D, lambda E, lambda F. I mean, okay with that? If I add it up, what will happen? I'll get X, Y, Z is equal to A plus lambda D, B plus lambda E, and C plus lambda F. Right? So I have X is equal to, A plus lambda D, Y is equal to B plus lambda E, and Z is C plus lambda F. Right? I have X, Y, and Z into the lambda. What do we call this form? This is your parametric form. Right? X, Y, and Z in terms of lambda. But okay with that? How do I get Cartesian form? Cartesian form means that only have X, Y, and Z. How can I do that? Any ideas? So basically, how can I get rid of lambda? And I can make lambda this subject here. Lambda will be X minus A on T. What about here? Lambda is what? Lambda is Y minus B all over E. And lastly, lambda is equal to Z minus C all over F. Can we okay with that? So since they all equal to lambda, then I could say X minus A is T, Y minus B is E, and and Z minus C is F. This here is what we call our Cartesian form. See that? So you have to be able to go from vector the Cartesian or Cartesian back effect. That's okay? Copy it down. Oh, we're getting for sure. Oh, you're going to sign up. So, fine, bigger one. Okay, maybe not one in the sport, right? Okay. Copy it down. Let's try one now. All right, let's go now. Try this one here. The line L passes through. Write it down. The line L passes through. The line L passes through the point E. The line L passes through the point E. 1 minus 3, 4. 1 minus 3, 4. And is parallel and is parallel to the vector 2i plus j 2i I. What's A again?
1 minus 3 plus 1 minus 3 plus.
And it is parallel to 2i plus j minus 3k. 2i plus j minus 3k. Find the vector equation of the line, parametric and Cartesian. Find all three. See if we can follow the steps I showed you here. Right, again, several I'll do it as now. Anybody have a five bit for 5 bit?
Yeah.
Just pass the wrong way in my email. But it's fill out that in 3 before. But that's the. Let's play anybody you work with. You want to get you? Right, let's see if you know what to do. So the first form is the vector equation. So we need a point 1 minus 3, 4. And we use lambda and direction vector. 2 minus 1, 2. Right? Point on the line. Point on the line vector. Are you okay with that? So this form here, we call this form the vector equation of the line. All right? Oh, sorry. Thanks. right? Next one is the parametric. So we have x, y, z. You all can see what x equals to? X is 1 plus 2 lambda. Everybody okay with that? Y is what? Minus 3 plus 1 lambda. And the z is 4 minus 3 lambda. Right? Vector, parametric. How we getting Cartesian again, Joseph? How we getting the Cartesian? Make lambda the subject in all, right? So that'll be x minus 1 over 2, y plus 3 over 1, and z minus 4 over minus 3. All right? And this one here is your Cartesian. Right? Do me a favor. Take this Cartesian and I want the vector form only. Right? What y'all got? Right? So you might recognize that all the values down here, right? All the values down here, those are your direction vector. 3, 4, 2. Do you recognize that? And then the opposite signs of these are the points. So that would be minus 2, 1, 5. Are you okay with that? So that's the answer. All right? No, I wanted. That's what I said. Parametric.
Yes, sir.
No, I said vector. I said vector. So I only want the vector form.
Yeah.
Now, imagine you have two lines. Those two lines could undergo either one of these scenarios here. Number one, the lines could be what? parallel. How do we show that lines are parallel? Parallel lines are? Look, how you could show it if you do have, you only have three equations.
Yes.
If you only have this, right? Parallel lines are multiples of each other. Question. If I ask you, are these two lines parallel? What you looking at? Very good. Look at the direction vectors, right? Parallel are multiples of each other. I'm making a note here. You're looking at the direction vectors. Very good. Nice. So if lines are not parallel, then the lines what? The lines intersect. The lines intersect, right? So what that means is that they have points in common. All right? But what is called this? Right? Can we have lines that do not intersect and are not parallel?
Yeah.
Those lines are called skewed lines, right? But I want you to have a little idea how they look, right? What is here? Right? If I were to draw these two lines out and they're looking like they might intersect, but suppose the lines on different planes. So pretend this is one plane with a line and the next plane with a line, right? Two planes, right? And it have a line on it. If I draw a line like this and a line like this, would those two things ever meet? No. Remember, we're dealing with 3-dimension now, right? These diagrams are like 1D diagrams. So that's why it's looking like they might meet. But if I draw a line on this plane and this plane, those lines will never meet. Right? They're not parallel and they do intersect. So whenever these two things happen or don't happen, they are said to be skewed. All right? Skewed lines are not parallel and they don't intersect. That's okay? So I'll try to draw it here for you, kind of hard, but I'll try to draw it here for you. This is one plane and the next diagram is a second plane. That's okay? Those lines will never meet. All right? There's always a space between them, they'll never meet. Right? Skewed lines. So skewed lines are not parallel and do not intersect. Let's see how we're going to show that now. Let's see how we're showing that. All right. Let's go with line 1 and line 2. Everybody ready? Let's check out line 1 and line 2. So the first one I am doing, I will do line 1 and line 2 for you. So we have to check and see here, Joseph. So when you finish the game, I know. Please play all the wrong, sir. Right? So let's take a look at line 1 and line 2. Right? If you look at line 1 and line 2, are they parallel? Look at these two. Are they parallel? No. No, not parallel, right? So the first thing we're saying is that they are not parallel because there's nothing I can multiply this by to get out. That's okay? Not parallel. So they're not parallel. Let's check and see if they intersect. Right? What would happen if they don't intersect? If they don't intersect, then it's skewed. All right? So I want you to follow the process, right? What we're technically going to do is solve these simultaneously and see if we get an answer. If we get an answer, they intersect. If we don't get an answer, they are skewed. All right? Are you ready? So watch this here, right? So they are not parallel. Let's check and see if they intersect. So in order to solve, we need the parametric form. All right? So let's take L1 and get the parametric form for L1. Parametric form for L1 is x is equal to minus 5 plus 6 lambda. Y is equal to 2 minus 3 lambda. And Z minus 3 plus 9 lambda. Anybody confused? Everybody okay? Online, are you okay too? Same thing for line 2. Minus 5 minus 2 mu. Y is equal to minus 4 plus 3 mu. And Z is equal to, right, 3 minus 5 mu. 3 minus 5 mu. Nice. What are we going to solve? We are going to solve x and y simultaneously, right? Here's what we're doing, right? If these two things intersect, then this x value should be the same here, and this should be the same here, correct? So we could say that if they intersect, right, minus 5 plus 6 lambda should be equal to minus 5 minus 2 mu, and 2 minus 3 lambda should be equal to minus 4 plus 3 mu. Are you okay with that? These two things should be equal, right? Let's solve them now. What will happen here? That will cancel. I can divide by that. I am getting mu to be equal to minus 3 lambda. Right? These two cancel. I divide by minus 2. I get minus 3. So I know what mu is, and I'm going to drop in mu here. So mu is minus 6 lambda. Sorry, minus 3 lambda. Everybody okay with that? I just put it in here, right? Okay, Shab, you okay? You sure? So this is 2 minus 3 lambda is equal to minus 4 minus 9 lambda. Bring everything across. I got 6 lambda to be minus 6. Lambda is minus 1. Everybody okay with that? If lambda is minus 1, mu is what? If lambda is minus 1, mu is positive 3. Are you okay with that? Right, now is the important part. Right, now is the important part. We found lambda to be minus 1 and mu to be 3. So here's what we're doing. For L1, we're going to find Z. Z is equal to minus 3 plus 9 by minus 1, which is minus 12. Good one? You okay with that? I'm going to find Z here. Right? I'm going to find Z for this. So Z is 3 minus 5 by mu. Mu is 3. I got 3 minus 15, which is minus 12. Are they equal? They equal. What does that mean? They intersect. Everybody okay with that? Chloe, do it myself. Right, so all I did, Chloe, is I made x is equal, y is equal, and I solve for lambda and mu. Right? When I solve for lambda and mu, plug it in here, and we're done. Right? If these values are equal, then they intersect. If they are not equal, they don't intersect. Double? Double? Okay. Copy it down. And I want you to work out L1 and L3 and L2 and L3. Right? L1, L3 easy. Right? But L2 and L3 a little more work, right? Online, any questions? All you're doing, parametric form, equate the x's, equate the y, solve for lambda, solve for mu. And then plug them in here. Copy it down, that's it. Everybody name here? But just tell them why. Find L1, L3, which really easy, and then L2, L3. So you That's it. Huh? See, I think anybody else sign? Anybody else sign, right? Everybody sign, right? With that, okay, give me right? Right, you doing L1, L3, L2, L3. So you do right.
Yeah. Nah,
I got I got you. How was it? Parallel or not? Huh? Parallel or no? Right, nice. 1 and 3 are parallel. Right, 1 and 3 are parallel because direction vectors are multiples of each other, right? So if I multiply 2L3, I'll get L1. Sorry. 3L3. I multiply this by 3. I'll get this. Right? So our focus now is L2 and L3. Right? We already have L2. We already have L2. We did it the last question. 3 minus 5 mu. And now L3, there's nothing else to do here. Parallel lines going one intersect, right? So they're coming in right here to L3. What was L3? 2 plus 2 gamma minus 3 minus gamma. 6 plus 3 gamma. And then equate. Right? You don't have to equate x and y if you can equate y and z. It don't matter, right? Put your values back into the next one. So I equating these two here, that's minus 5. And then I equate in here, minus 4. Huh? Marker finish. Right? What I can do here, I can make gamma the subject, or I can multiply this by 2. So I'll get minus 8 plus 6 mu minus 6 minus 2 gamma. And then I could take equation 1 and equation 2 and add them. So I'll get what? Minus 13 plus 4 mu is minus 4. This will cancel. Right? So when I carry that there, I get fraction. Right? I got 4 mu to be 9. 9 on 4. Anybody got 9 on 4? No? What I get from you? Anybody reach here? What I get from you? How much you got? Coming up. Normally you just get whole numbers. 3. Alright, let's see if I write down the wrong thing for I multiply by 2 minus 8 plus 6 minus 6 minus 1. Add minus 4, that's 0. That's 4.
I love it.
Yeah, that's correct. It's fractions. Right? Fractions, right? Right? 9 on, let me just make sure I add right do it. That's 13. 4. Right, nice. And then solve for gamma. What you got for gamma? It's a fraction, right? Supposed to be a fraction. Huh? How much you got? From where you got them? What's your fraction? 9 over 5. So I just add here. I add here, I get 4. And I add here and I got minus 4. And 13 minus 4 is 9, right? Right? Anyway, we'll work with that, right? And then when you solve for gamma, gamma is what? We're going to work out gamma properly. So that's minus 5 minus 2 by 9 on 4. 2 plus 2 gamma. Right? So that's minus 5 minus 9 on 2. Somebody can help me here? Gamma is how much? Gamma is how much? Put in the calculator now. Put in the calculator now. Come on, here. Minus? Minus 23 and 4. And lastly, we had to find Z. So for L2, Z is equal to 3 minus 5 by 9 on 4. And for L3, Z is equal to 6 plus 3 by. And then you would recognize that they are not equal. Therefore, skewed. L2 and L3 are skewed. Are you okay with that? I know it's a little bit long, but these are the questions will come. Right? These are all the questions will come. Right? We have one more to do. Oh, it's 54 already. All right, just last thing here. Watch here. I'll take copy it down, right? Suppose they ask, Ethan, suppose they ask you to find the point of intersection. What you will do? How you will find the point of intersection? All right. So plug in lambda here, lambda here, lambda here. And then write down what's x, y, and z. Right? Alright, we don't have time for our next one. But you just follow what to do,
Yeah, of course.
right? But I think the mistakes is here, right? Solving simultaneously. Right? So take your time. Do over this one in case mine's wrong, eh? Do it over. But the answer is equal.
But it's not really simultaneous,
Yeah.
Yeah.
You'll get both sides. But I provided that in both sound like this. If it were equal now, then it would have get wrong. Alright, we'll stop there for today. Right, next day we'll finish up module 2 with vector equation of plane and start mod 3. Yeah. Right, module 3, I'm trying to give you a handout for you to write in, huh? Everything in module 3. Oh no, I can just use a workbook.